OSIRIS-REx in NASA's repertoire. I like to call it the Daredevil spacecraft.
10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of OSIRIS-REx, its 7-year mission to boldly go to the asteroid Bennu and back.
Good afternoon, everyone. Welcome to today's media briefing on the upcoming asteroid sample return of NASA's OSIRIS-REx mission. I'm Patrick Lynch with NASA's Office of Communications, and I'm joined today by mission representatives from NASA, the University of Arizona, and Lockheed Martin. We're broadcasting today from inside a hangar at the Army's Dugway Proving Ground in central Utah. And 24 days from now, in the high mountain desert of the Utah Test and Training Range, several miles behind us, the OSIRIS-REx mission will deliver to Earth America's first ever sample from an asteroid. The mission team earlier today completed a drop test with a replica sample return capsule. And today they will share details of that test in addition to details of the final preparations toward the sample return, the climax of a 7-year journey from the 2016 launch at Kennedy Space Center to the sample collection at the asteroid Bennu in 2020 to the return to Earth here on September 24th. With us today, we have leaders of the OSIRIS-REx mission. Melissa Morris, the program executive at NASA headquarters. Rich Burns, project manager based at NASA's Goddard Space Flight Center. Sandra Freund, Lockheed Martin's program manager for the mission. Kevin Ryder, the OSIRIS-REx deputy curation lead at NASA's Johnson Space Center. And finally, Dante Lauretta, the mission's principal investigator based at the University of Arizona. After remarks from our panelists, we'll open up to questions from the media in the room and on the phone line. For those on the phone, you can press *1 to get in the queue and ask a question. For those in the room, you can raise your hand. We'll bring a microphone to you. And with that, I will turn it over to Melissa Morris.
Thank you, Patrick. I am so very excited to be here as we head into the final stretch of the delivery of these valuable and long-awaited samples back to Earth. As you may know, NASA's goal for science is to create a global community for exploration and discovery that fosters innovation and inspiration. And to that end, NASA invests in small body missions like OSIRIS-REx to investigate the rich population of asteroids in our solar system that can give us clues about how the solar system formed and evolved. It's our own origin story. And remember, the O in OSIRIS-REx is for origins. The planetary science mission fleet is huge with nearly 40 missions. And 3 of those missions to small bodies are being showcased this fall in something we're calling Asteroid Autumn. In September, we have, of course, the delivery of those samples from Bennu by OSIRIS-REx. And in October, we have the launch of the Psyche mission to a never-before-seen metal-rich asteroid. And finally, in November, we have the Lucy flyby of an asteroid in the inner main belt with providing a test of their innovative autonomous terminal tracking system. And so OSIRIS-REx, we're kicking off Asteroid Autumn. OSIRIS-REx is a part of the Planetary Science Division's New Frontiers program, which supports medium-sized missions that are competed and PI-led. OSIRIS-REx was a result of the New Frontiers 3 announcement of opportunity. It was selected in 2011. It launched in 2016 spectacularly, on time, and arrived at the asteroid Bennu in 2018 to begin an 18-month survey of the surface of the asteroid, in part to select a sample site for collection. And those samples were successfully collected in October 2020, and then OSIRIS-REx headed home with the sample in 2021. And guess what? We're just a few weeks away, get a little bit clumped, from the delivery of those samples to the Utah desert. And so OSIRIS-REx is a phenomenal mission. It has achieved so much already. It's the first U.S. mission to return samples from an asteroid. And that sample mass collected is the largest from beyond the orbit of the moon. And on a personal note, this mission is so important to me. It's directly applicable to my research into the formation of the solar system and early solar system materials, in particular components that can be found in meteorites that are thought to come from parent bodies that are very much like Bennu. So I am so excited to see what's in these samples. And I'll turn it over to Rich for a project overview.
Thanks, Melissa. I'm Project Manager Rich Burns. I'm at NASA Goddard Space Flight Center. I've been the project manager of OSIRIS-REx since launch. It's been an extraordinary journey of adventure and exploration. This mission is one pure exploration, meaning we didn't really know much about Bennu before we launched, so it surprised us in just about every dimension. Dante called it the Daredevil spacecraft. Well, all daredevils practice, and that's what I'm going to talk to you about a little bit today. At least all daredevils that live to tell the tale, right? And we are survived coming home. So we're very excited to be in the final phase of this long journey, 7 years, as you saw. The journey started even before that. Dante's been running this marathon for a very long time. So how do we prepare? The Roman philosopher Seneca said success is when preparation meets opportunity. We're very fortunate to be in the position to be privileged, really, to be a part of this mission of exploration. So we take very seriously our preparation. The preparation consists of both tests and rehearsals, maybe indistinguishable to a lot of people, but we call tests when we're practicing commanding with the spacecraft, but we use a simulator instead, much as a pilot would fly a flight simulator. Rehearsals, we put our team in the field, in the environment they're going to be in, using the communication tools and the equipment they're actually going to use on the day of recovery. And you're going to see some of that from us in the upcoming graphics. Today, as Patrick mentioned, we conducted a drop test from a helicopter. So we dropped a replica, as you see right here. This is the real replica that we dropped from the helicopter about 7,000 feet altitude. It deployed its main parachute. This represents the final phase of flight for OSIRIS-REx sample return capsule and the sample being delivered home under the main chute. The descent is quite gentle from this point forward. It comes screaming into the atmosphere, but this main chute slows it down significantly. This is our first opportunity to work with our colleagues at the Utah Test and Training Range to track the capsule as it descends under the main parachute using the sensors that are here at the range. That worked beautifully to locate the sample, the location of the landing, and then recover the capsule from there. Yesterday, we placed the capsule on the range and practiced our recovery techniques. And here you see we are recovering the capsule with 4 helicopters that deploy our recovery team. First, to ensure the area around the landing is safe and secure. And then the recovery team approaches the capsule to prepare it for transport back to a clean room, temporary clean room that we've assembled here at the range. This takes quite a bit of processing on the ground before the capsule is ready to be transported. Human safety, as you're going to hear from me in a bit, is our #1 priority. So we make sure that the capsule itself is ready for transport, prepare it, put it in a cargo net, and transport it back under a long line via helicopter to a building you saw this afternoon with a temporary clean room embedded in it. We land under that long line, and the capsule itself gets transported into the building and into the clean room itself for disassembly, and ultimately, as you'll hear, transport to our curation facility. We're very excited about this process, but let me tell you a little bit about what precedes the reentry. We have major decision just 4 hours in advance of when that capsule enters the Earth's atmosphere. That's whether the spacecraft will release the capsule or not. That decision is based on 3 criteria. Human safety is our #1 priority, as I said. Capsule survivability. The environment, as you'll see, is very harsh during the atmospheric reentry. Capsule reenters at 12.3 kilometers per second and heats up very quickly. And then the third is landing accuracy. Can we land in the prescribed area that we know is going to be safe and free of people? So back in July, we started a sequence of maneuvers that are intended to target the Utah Test and Training Range. The first maneuver, conducted in July, targets a path, moves the path of the spacecraft to within 125 miles of the Earth. Then on September 10th, we'll target the Utah Test and Training Range, followed by a maneuver 1 week later to refine that targeting. And as you're going to see later, we have a very relatively small area to fit in, but we're highly confident we'll hit that. After we release the capsule, we make the decision at 2 a.m. in the morning, the day of release. We'll release the capsule at 4:42 Mountain Time, assuming we decide to release it. And then 20 minutes later, the spacecraft will make another maneuver to avoid Earth, and it will be on to its extended mission to a soon-to-be famous mission, or asteroid called Apophis. We're very excited about that extended mission. We're here to talk about the primary mission. Following all that, we will be targeting the Utah Test and Training Range. It's a beautiful place to land a sample capsule. Why? Because it's enormous. Its expanse is mind-boggling, really. Texas may not have much on Utah in terms of everything bigger. Utah is pretty darn big. So we will be targeting an area, an elliptical-shaped area, marked here as our expected landing area. We will have to be sure that the capsule will land in that area. We'll make that decision at 67,000 miles away from Earth. That capsule will be released at 67,000 miles away from the Earth. And we'll hit that landing area is about 250 square miles. It's equivalent of throwing a dart across the length of a basketball court and hitting the bullseye. So with that said, I'm going to turn it over to my colleague, Sandra Freund from Lockheed Martin.
All right, thanks, Rich. So like everybody else on this panel, I'm really excited that we are less than a month away from returning these samples. So I'm going to take you back a little bit in time before we get on the ground. And just like the recovery team, our flight operations team is busy practicing and rehearsing everything that we need to do in order to ensure that the sample return capsule is released. So like Rich mentioned, we have that go, no-go decision point. We fully expect that decision to be a go at 2 o'clock in the morning, local time, on September 24th. So at that point, the mission operations team, which is located at Lockheed Martin in Littleton, Colorado, will be sending the commands to the spacecraft that will start the sequence to do all the events that are needed. So we have an animation here that shows actual release from the spacecraft. So we need to make sure that we configure everything, we're pointed correctly, and then we will let go of the sample return capsule. Shortly after that, as Rich mentioned, we will do a divert maneuver to make sure that the spacecraft bus does not follow the capsule in. We have a very long 4 hours from release until re-entry into the atmosphere. You can see there, we will re-enter at about 27,000 miles per hour over the Utah Test and Training Range. We'll deploy a drogue chute autonomously that will stabilize the capsule, followed by the main chute, and that's what we rehearsed today. That main chute gets us to a nice, gentle 11-mile-per-hour touchdown here in the desert. Our recovery teams will be standing by, waiting to get the all clear to go ahead and approach the capsule. So that series of events leading up to entry are shown in our next graphic. That breaks it down to what actually happens in the 13 minutes that it takes from when we enter the atmosphere until we make that gentle touchdown here in the desert. So our recovery team is made up of people from Lockheed Martin, NASA, Curation, and folks from the Utah Test and Training Range. They're standing by. Once the capsule's on the ground, they will then approach it. Again, keeping in mind safety first for both people, followed by sample. We will take a look at the capsule, make sure it's safe to approach it. We'll approach it, do some initial checks out in the field, and then ready it for that long line flight that Rich discussed. Once we get it back into our clean room here at the Utah Test and Training Range, there'll be a little bit of disassembly that will take place. The primary goal to get the nitrogen purge onto our sample to keep it pristine. Then we will ready it for shipment. So it will be placed inside a specially designed shipping container where we will fly it the following day on a C-17 aircraft from here in Utah down to Johnson Space Center. So I'll turn it over to Kevin to talk more about the curation side of things.
All right, thanks, Sandy. So I'm Kevin Reiter. I'm the OSIRIS-REx Deputy Curation Lead from Johnson Space Center. And Johnson Space Center is the home of NASA's astromaterials. We have a lot of collections there. For example, the Apollo lunar samples, meteorites from Antarctica. We have comet samples brought back by the Stardust mission, and we have solar wind ions brought back by the Genesis mission as some examples. And we're very excited to have the opportunity here to add a new collection to our astromaterials collections, carbonaceous-rich asteroid material from Bennu. So the, curation is all about keeping the sample safe and clean and uncontaminated. And our curation team has had two major activities related to the recovery. And I'd like to spend the next few minutes explaining those two and what our team has been accomplishing. So the first area is to aid in the recovery, and so some of the footage you see here is the rehearsing by the field recovery team, where we have curation scientists part of that team. They'll be collecting air, soil and water samples around the SRC on return, and the reason we're doing that is to understand the nature of the landing site, and so that we can assess potential contamination later on. We want to have a really good understanding of where it landed and the composition of the material around the capsule. So in addition to the field activities, as Sandy alluded to, our team has established a clean room in a nearby building here, and the clean room will be where the capsule is brought in from the range. The clean room, we've been working on this for a couple of months. Activity started back in June, and we have now, as you can see, established a fully functional clean room ready to receive the sample. The purpose of the clean room is to allow our team to prepare the sample before it gets shipped off to Houston, and so we're really excited about that. So those are the recovery efforts. The other effort, major effort the curation team has been involved with, is establishing a new clean room in Houston, and you see some footage there from that clean room. The clean room was established as a dedicated clean room for this sample so that we do not cross-contaminate with other collections. So we will only have Bennu samples in this clean room. And you can see in the footage there are two main components to the within the clean room. There are two nitrogen glove boxes that the sample will be handled and processed in, and this is to protect the sample from contamination. Again, the goal is to be clean and uncontaminated. And so the first glove box you see there, the larger glove box, will be where the lid is removed from the sample canister. That will reveal the TAGSAM collector head that collected material directly from the surface of Bennu. Once that is revealed and removed, it'll be temporarily contained and transferred to a second glove box. In that second glove box, the TAGSAM will be disassembled, and that'll take some time, so it'll be a long several-week process to get in to reveal the bulk sample that lies within all of that hardware. So once that occurs, we will start to characterize the sample, understand better what we have, how much we have, how many different rock types and lithologies there might be within the sample. The characterization will be used to determine material that we allocate to international partners from JAXA and the Canadian Space Agency, as well as determining what material will be appropriate to allocate to the science team for their studies. And with that, I think I'll turn it over to Dante, who will tell you more about the science.
Thank you, Kevin. It's really amazing to be here today. I've imagined the series of events that we've been rehearsing for literally almost 2 decades. And I have the honor of sharing the stage with these amazing people, and they represent organizations that have brought hundreds of individuals to achieve this mission success. As you can see from the first graphic here, I've grown up on this program. I don't even recognize this kid from 2008 who was writing that New Frontiers proposal to convince the agency to let us lead this program to bring back these amazing samples from the dawn of our solar system. Launching in 2016 seemed like the highlight of my career at the moment, but it was really just the beginning of getting us to this incredible world, this small asteroid named Bennu that holds clues, we believe, to some of the deepest questions that we ask ourselves as humanity. Let's take a look at the asteroid. It's a stunning celestial object. To give you a sense of scale, it's about 500 meters or a little over 1,600 feet in size. That's about the size of the Empire State Building, or like a small mountain. I like to think of Bennu as a small mountain floating in outer space. And its shape is particularly intriguing. It literally is a droplet made out of rock, gravel, and boulders that are barely held together by their own microgravity. And it was amazing to have our spacecraft visiting this celestial neighbor for over 2 years with our prime focus of picking that key location on the asteroid surface where we sent the TAGSAM, the touch-and-go sample acquisition mechanism, which you can see here, the forearm of that device, make that brief contact with the asteroid surface. And it was a really dynamic event. Bennu, I call the trickster asteroid. It has challenged us every step of the way. We thought for sure we were going to touch down on a solid surface. This was an asteroid. It was a rock from outer space. But it actually responded more like a fluid, like if you dropped yourself into a ball pit at a children's playground. The good news was, because of that really soft surface, we collected an enormous amount of material. We promised the agency we would bring back 2 ounces, or about 60 grams of material. We believe, based on some very clever spacecraft engineering from our partners at Lockheed Martin, measuring the momentum change on the spacecraft as we articulated that robotic arm, that we have at least 4 times that material in that sample return capsule. So over 8 ounces, or about 250 grams of material. And boy, is the science team excited to get that. In addition to being the principal investigator, I'm also on the field recovery team. I wanted to personally be out there to greet these pieces of Bennu to our home planet, welcome them to the curation facility at Johnson Space Center, and get them ready for the adventure we're about to put them on. At the University of Arizona, we've been building world-class laboratory instrumentation. We have some state-of-the-art electron microscopes, ion microprobes, a whole suite of ancillary equipment. And one of the best parts about being at a university and being able to lead a program like this is that we're training the next generation, right? I've had over 200 students, undergraduates and graduates, working in science, engineering, analysis, chemistry, marketing, graphic arts, video production, business management, all of the skills that it takes to bring a mission like this to a close. And we have an army of graduate students that are waiting to get involved in the sample science program. It's really a great entry point for young people to get involved in science. They're super excited just to think that we've got these pieces of asteroids. And then I start to explain the story of what these samples are going to tell us. We're going back to the dawn of the solar system. We're looking for clues as to why Earth is a habitable world, this rare jewel in outer space that has oceans, it has a protective atmosphere. We think all of those materials were brought by these carbon-rich asteroids very early in our planetary system formation. And of course, the biggest question, the one that drives my scientific investigations, is the origin of life. What is life? How did it originate? And why was the Earth the place that it occurred? And because Bennu is so rich in carbonaceous compounds, we've seen these with remote sensing instruments that we used while we're at the asteroid. We believe that we're bringing back that kind of material. Literally maybe representatives of the seeds of life that these asteroids delivered at the beginning of our planet that led to this amazing biosphere, biological evolution, and to us being here today to look back on that amazing history, to think about where did we come from and where are we going? What does it mean to be alive, to be conscious in this amazing universe? Let's take a look at the last graphic. This is where we think it all began. We call this the protoplanetary disk. This is where stars are born. And when a star is collapsing, it spins out this disk of gas and dust, and that's where chemistry and physics start to work together to build initially dust grains, literally like snowflakes made out of rock and metal and sulfur and organic materials, ices that accrete together. They grow into asteroids and they grow into planets. So the asteroids that we have in our solar system today, they're left over from this earliest stage of solar system history. We're literally looking at geologic materials that formed before the Earth even existed, right? I call these like the grandfather rocks, the ones that really represent our origins and where we came from. And I know they've just been waiting for 4.5 billion years to get into that sample return capsule, get down to the Utah desert, safely get to the amazing facility that our colleagues at Johnson Space Center have put together. And Kevin talked about protecting, making sure they're pristine, but a big part of the job is also getting that material out to the scientific community. This is a gift to the world. We have laboratories on 4 continents, 16 time zones, hundreds of researchers, over 60 laboratories that have been getting ready to get this material, and we are ready to begin the final science campaign of the OSIRIS-REx prime mission. So with that, I'll turn it back over to Patrick.
Excellent. Thank you for wrapping that up, Dante. Thank you to all the panelists. Let's get to some questions. Again, in the room here, please raise your hand if you have a question. Sophia will get a microphone around to you. And if I don't see any off the bat, here we go, up here, Sophia. And for those on the phone, please press *1 to get in the queue. We will get to you shortly. Thanks.
Hi, I'm Yu Inoguchi for Kyodo News, Japanese news agency. My question is, you are going to exchange the samples with JAXA or Hayabusa 2 team. And what is, would you please explain a little bit about the importance of studying 2 similar but different asteroids rather than just one? And what you are looking forward to seeing through the international cooperation? Thank you.
I think I'll start. Maybe Melissa might want to say something as well. But I want to say we've had an amazing partnership with our Japanese colleagues and the Hayabusa 2 mission. We recognized early on that we were much stronger together and that the science return was going to be exponentially larger by having these 2 asteroids to compare and contrast with each other. So the Hayabusa 2 mission went to an asteroid named Ryugu. It actually looks a lot like Bennu. It's got that, what we call the spheroidal or spinning top shape, these fluids made out of rocks and gravel. And we exchanged lessons learned. We worked together defining our science programs. Rich and I and colleagues went out to visit JAXA to talk to them about how their sampling events went and take that information back to us. And already the Ryugu samples have provided amazing insights into the origin of the solar system. And I'll say, when I saw what Hayabusa 2 brought back, I was like, okay, that's really similar to the kind of material we have, but spectrally these asteroids look very different. So it actually made me think, well, what exactly are we bringing back? We might be bringing back something we haven't seen in our meteorite collections, and actually that's what I'm really getting excited about. Maybe, Melissa, you want to talk about the interagency cooperation?
Absolutely. And as I mentioned before, NASA really wants to be a part of a global partnership that does exactly what Dante says. We work with our partners. We're stronger together. We cannot do anything alone. I think we all know that. And to just play on that, 2 different asteroids that may photograph and look a little bit the same can be very, very different. And with my history with meteoritics, I think the thing that would make me the happiest is if we have something totally different. And you can have 2 meteorites that look identical and can be very, very different. And so it's so exciting to be working with both the Japanese and the Canadians, and we want to be stronger together to investigate these big problems and where we came from.
Okay, take our next question from the floor, right at the back. Oh, wherever you find him.
Hello, I'm Justin Davenport from NASA Spaceflight. We all know what happened to the Genesis sample return mission. Had issues getting back down. What have you learned since then that you've been able to apply to this mission?
I'll take that one. We have learned a lot from Genesis, right? Every success and every failure has lessons learned. We are very confident that we've taken the lessons learned forward from Genesis into OSIRIS-REx. We have done an extensive test program on our sample return capsule before we launched it, and continue to look very deep inside of the capsule to make sure we understand absolutely everything that's in there. Now, sample return missions are hard. There's a number of things that can go wrong. Our ground recovery team is ready for any scenario that is to happen. We fully expect that sample return capsule to land very gently on its main parachute, but they are prepared in the event that it is not.
Okay, let's take, go ahead and keep raising your hands. We'll move the mic around in the room. Next question we're going to take from the phone line. Marcia Dunn from the Associated Press, you are up. Go ahead.
Can you hear me there?
Yes, we're coming in now. Go ahead.
Oh, great. Thank you. Probably for Dante, I'm not sure. You mentioned 250 grams anticipated coming back. I keep reading about a cup of the material, debris, rubble, filling up. Would about 250 grams fill about 1 cup, maybe more? And what do you think is the most that could be coming back in samples? I heard 67,000 miles, I think, at the time of release of the sample container. Is that the closest that OSIRIS-REx will actually come to Earth, or does it get any closer than that? And lastly, when will this science campaign begin? Might it begin by the end of the year? Thanks.
Sure. I think I'll take the first and the last question and turn it over to Sandy or Rich for the spacecraft attitude question. So the 250 grams is a little over 8 ounces, which is a cup. It really, of course, the volume depends on the density, but we think Bennu is really low density material. Just for reference, a rock that you would find, say, out here in the Utah desert, about 3,000 kilograms per cubic meter. The bulk Bennu asteroid is about 1/3 of that, which is just above that of liquid water, which is a shockingly low density for geologic material. And then when we looked at what happened when we made contact with the asteroid surface, it was about half that. The area where we contacted the Bennu was about 500, so 1/6 the density of your average rock. So a cup is a good visual assessment. Of course, we don't know how the material is going to respond in the gravity field of the Earth, and it may compact, but based on what we know about the bulk density of Bennu and the mass that we estimate that we've collected, that's roughly of order of 1 cup. In terms of when the science campaign is going to start, I'm obviously pushing for as fast as possible. And the good news is we've worked with our colleagues at Johnson Space Center to identify the ability to sample very quickly in the processing. When we stowed the TAGSAM device inside the return capsule, it was leaking material. It was a moment where we rallied, overcame the obstacles, and safely got the material stowed away. But there's probably particles that are moving around inside the science canister. So any dust that's visible as soon as we open up the canister, which might be as early as September 26th, there's going to be a sample, like a wipe taken, and that material is immediately being delivered to a quick look analysis team ready at Johnson Space Center, which in addition to having a curation facility actually has an amazing sample analysis suite of instruments as well. And we're going to get busy. University of Arizona researchers, NASA researchers, we have colleagues from the Smithsonian, from Purdue University. They're going to be ready to receive that sample and get us an immediate assessment. And I want to know, did Bennu trick us again? Is it what we're expecting, or are we looking at something completely unanticipated? And as a scientist, that's kind of what you hope for, right? Because that's where the real secrets are unlocked. And I don't know who wants to take the question about the attitude of the spacecraft.
Yeah, the spacecraft following the divert maneuver targets a flyby of Earth about 800 kilometers. That will set it up on a path around the sun, and we'll be making maneuvers in the months after the divert to target our next target, which is the asteroid Apophis for our extended mission, which we'll rendezvous in 2029 with.
Okay, great. Let's take our next question from the phone, and then we'll go to the floor next. So I believe Gina Sinceri from ABC News, you are up next, and go ahead with your question.
Thank you. This is for Dante. Could you tick-tock for me quickly what the nail-biting moments are for you guys?
Yeah, you know, it's been amazing to look back on this journey, and, you know, I ask myself, how many heart-pounding moments can you have in one lifetime? Because I feel like I might be hitting my limit. To me, of course, it's the go, no-go poll. I've already voted, for the record, it's go from the PI. So that's literally on the record. They don't poll me. They know my opinion. But there's human safety, and I understand. That's why I have Rich as the project manager to make that call, and I trust him implicitly to do that for us. So, of course, if we don't release the capsule, then there's no work to do here on the ground, and we're waiting 2 years. There's an opportunity in 2025. It's risky. We have to get close to the sun beyond what we tested the spacecraft to do. We don't want to do that. We want to release that capsule. And then it has to separate from the spacecraft. There's some action. There's cables that need to be cut, and a mechanism that pushes and spins the spacecraft out. That has to work properly. And then, of course, we have to deploy the parachute. And that requires batteries to be depassivated. We'll have information before we release the spacecraft. And it was great to watch the drop test today. It was just like a little sneak preview of that emotional moment. As soon as I see that parachute unfurl, I know we made it. We made it to the surface of the Earth. We've achieved that mission success criteria to safely get that sample down to the ground. And at that point, I think it's all downhill from there. Everything we've rehearsed, getting out of the field, getting it to the clean room, getting it on an airplane, getting it into the curation lab, I think that at that point, it's just fun and games and sample science.
Okay, great. I think our next question from the floor right here. Sophia has a microphone. And if you could state your name, and if you know who the question's for, go ahead and direct it to them.
I do. Thank you. Chris Kokinos. I'm writing for Astronomy Magazine. I actually have a couple questions. One, I think, for Sandy, and then a question or two for Dante. For Sandy, can you talk about, or whomever, can you talk about when you are getting the sample return canister into that cargo net? What are you wrapping it with? What are you sort of putting it in, or does it just go into the cargo net?
Yeah, it is wrapped in bags. Do you have the exact material? Curation Teflon bags. Yeah, before it's placed into a handling fixture that is then hooked to the long line from the helicopter.
All right, awesome. And then for Dante, are you planning on being one of the people carrying it?
I won't touch the hardware.
Okay.
That's Lockheed Martin's job, and that's their responsibility. They're responsible for actually transporting it all the way to NASA Johnson Space Center, and even opening it up. And at that point, it's handed over to JSC, and it becomes part of the collection. I'm there to document the environment, right? Our goal is to bring back pristine asteroidal material.
Right.
And pristine means that nothing that gets introduced that's not from the asteroid hampers our ability to analyze the material. One way you overcome that, because we're out in the desert, it might be wet, it might be muddy, windy, dust-blown material. Some of that may make its way into the collection. It's unlikely, but we want this contamination knowledge collection. If we see something that looks really unexpected, like one thing I noticed out there were snail shells, right, where we were rehearsing. I was like, if we found a snail shell in the collection, we might want to say, could that have come from Utah? Right? We don't want to publish our science papers unless we're really, really sure. So it allows you to eliminate false positives, remove blanks from your chemical analyses, and have that information. So I'm out there with members of the curation team and the science team to make sure we get the samples that we want for that information.
Okay. And then just lastly, how hydrous is Bennu? I mean, is there any chance that there might be some interesting biotic or even almost biotic chemistry? I mean, is that the kind of dream scenario?
Bennu appears to be heavily hydrated, and we have an instrument on there. It's called the OSIRIS instrument. It was built by our team members at Goddard Space Flight Center, and it looked across wavelengths in the infrared beyond what human eyes can see. And there's a drop in signal, a long wavelength that is very indicative of water molecules. And you might think, well, this thing's in the inner solar system. It's a near-Earth asteroid. The surface is way too hot for liquid water or for icy water. It's inside clay minerals. It's locked inside a crystal structure. My estimate is about 10% by weight of the asteroid is water, and maybe 5 to 10% by weight is carbon. These are, my bets. We're going to have to analyze it to see how well we did with the instruments, and that's one of our science objectives. In terms of could it have biotic material, that's a vanishingly small probability. We worked hard with NASA's Planetary Protection Officer to evaluate that. We're unrestricted Earth return. We're not doing biohazard containment or anything like that because that risk is vanishingly small. But we do think that there may have been evolution of the organic molecules that could give you insights into the initial stages of the origin of life. One of the things we see on the asteroid that we haven't seen in Yugu samples and we haven't seen in our meteorite collections are hydrothermal mineral deposits, long veins of salty materials that suggest a hydrothermal system very much like what we get at the deep ocean, mid-ocean ridge, what we call alkaline hydrothermal vents, which is a key environment where we think origin of life chemistry may have started. So what I want to know is how do you go from a simple carbon molecule like methane, which is a natural gas, to something like an amino acid, which makes our proteins, or a nucleic acid, which makes up our genetic material. So we're looking for anything that might get you down the pathway to a biomolecular system.
Okay, great. Let's take a next question from the phone, and then after that we'll go to the floor. So if you have a question here in the room, go ahead and raise your hand. But our next question from the phone, from Marina Corin from The Atlantic. Go ahead.
Hi, I'm Marina Corin with The Atlantic. Can you describe the immediate actions that would be taken in the event of a crash landing, like the top 35 actions? And then let's say there was a crash landing. Is there any scenario in which some of the samples could be preserved and be scientifically useful, or would it all be considered contaminated? Thank you.
I'll take the first part, take the second.
Sure.
So like I mentioned, the team is prepared for a hard landing scenario. The first thing is, of course, human safety. So we'll need to approach the sample return capsule. We know there is unfired ordnance, or there may be unfired ordnance in that scenario. We need to assess the state of the hardware on the ground to make sure that it is safe for people to approach what protective equipment that they need. After that, the priority moves to bulk sample safety, and if we can save the bulk sample, how quickly we can get that underneath some sort of purge. So
that's right. Yeah. So we have the tag SAM, which was that disc-like device, basically kind of an air filter where the bulk sample is inside an aluminum canister, which then has the heat shield and the back shell on top of it. So it will really depend on the situation and how we see the state of that hardware. But the goal is to get the canister and the tag SAM as quickly as possible into the clean room at the building here at the UTTR, and then survey the environment to see if there were some escapees, if some particles got out onto the Utah desert surface. And we have a very detailed plan. We'll grid out the whole area and painstakingly go through and evaluate all the material, probably collect a lot of Utah surface material, because we know we can still extract information. We may lose some of the more delicate compounds, but these things make it to the Earth as meteorites, so there's still going to be valuable science to do, even in the event that, the stuff of my nightmares, that the capsule parachute doesn't open and we're in the hard landing contingency. Fortunately, I have a backup team member who will help me with the emotional state, and also probably to be the one I send out there to go deal with it. But we've got a great plan. Curation team is ready. They've got the equipment. We've got a breach team, which actually Kevin is on, so you might want to talk a little bit about what you'll be doing to get ready for that scenario.
Yeah, well, I wanted to first just say that that's one reason, those sorts of scenarios are one reason to have a clean room established here, so we're ready to work on the sample in that unexpected state in a clean environment, safe environment, and have the time to do things correctly and in a as least contamination environment as possible. But we do have plans to have a breach team out staged at the edge of the landing ellipse, and the breach team will be able to go out and make an assessment of the landing area, coordinate with folks back here in this area to try to get people out there, get supplies. We'll have contingency supplies ready to go and staged, and get them out there as fast as possible.
Okay, great, thanks. Take the next question from the floor, the back of the room. Go ahead.
Thank you. My name is Spencer. I'm a reporter with Fox 13 News here in Salt Lake City. Welcome to Utah, everyone who's not from here. But my question's mostly for Dante or anyone else who'd like to answer this. You mentioned you wanted to be out there and greet the sample back home, greet it to Earth, almost like you're greeting a child. Is that just because you've been around this for so long, you saw it launch and you want to greet it back, or is it something more that you have this physical, emotional connection to this mission and to the sample? What drives that affection towards this mission and the sample that's being brought back?
Yeah, there's a lot of emotions involved right now. You know, when you think about the journey, how much I've learned, how much I've grown, the people that I've worked with, the amazing team. I mean, the best part of the program is the team, the people, the camaraderie, the unifying identity that OSIRIS-REx provides. So there's just emotion. The spacecraft carries emotion for sure. And I'll add to that. Yeah, but let me just finish. So Bennu is like an old friend, right? At this point, you know, even though it's a trickster, it likes to play jokes on us. It likes to challenge us. We thrive on that. And I really feel a connection to this asteroid. It's holding these clues, and I think it wants us to study. I think it wants us to unravel this mystery, to explore these giant questions. So yeah, I just felt like I had to be there. I just had to see the program, the flight program of the Prime mission come to a close.
Yeah, and as I said, I'll add to it, because before I became the program executive, I was the deputy program scientist for the mission. This is the mission that I always say was meant for me, because I've participated in research in almost every aspect of this mission except for, I think, one. I started out as an observational astronomer, went into theoretical astrophysics and meteoritics, and studying meteorites that are very much like this. And I've worked with the people that are on this team on both the science side and the engineering side, and this amazing team that has pulled off so many miracles. And to have that bonding event for a decade for me, decades for Dante, you can see how emotional I got even at the beginning, just thinking of the culmination, but yet still the beginning of what we'll find out. And so it's hard to remove the attachment and the emotion when you've been a part of something so wonderful.
Yeah, let me just say one other thing, right? We stand on the shoulders of our team. Our team has excelled at every step of this, met every challenge that we've asked and that Bennu has demanded of them. And one thing that we tend to do is anthropomorphize the spacecraft, right? Remember when we tagged? Remember when we orbited? We're not on the spacecraft, right? Kids say, is anybody on that spacecraft? Well, a little bit of us is on that spacecraft, and a little bit of us is coming home with that. It is very emotional.
Great, thanks. I think we have another question from the floor right here, and then we'll go back to the phone line.
Hi, good afternoon. Jeff Parrott with the Salt Lake Tribune. Again, welcome to Utah. Melissa, Rich, this is for the two of you. The well of conflict and problems here on Earth is nearly endless and expensive. So what makes going out and touching Bennu worth it? And like, what do we get out of it? Not just as NASA and Americans, but humanity.
I can take that first if you want. First of all, Utah is one of my favorite places, so it's always great to be here. I absolutely love it. To answer your question, first of all, we're a great country. We can do more than one thing. Great countries can do that. But on a more personal note, I used to teach astronomy, and I would tell my students, you know, what makes us different from every other creature on Earth is the ability to look up, I think. I do have a desert spiny lizard who might do this, but to look up and wonder and want to explore and to understand. And I think that is a fundamental need of humans. I think it is as important and can be as important as some of the other things that you mentioned. And so I think it is what keeps us going, what helps us overcome more difficult problems at times, is that ability to come together, diverse personalities, different motives, and come together as a team to achieve something great. And I think that's what makes it worth it.
Yeah, I think that's very well said, right? And I think when we stop exploring as a country, as a civilization, we stop growing, right? We stop coming together. We find ways to come together through this process. We executed TAG in the middle. We didn't even talk once about COVID here. We did the hardest part of this mission in the depth of COVID, right? And it really showed, it was a really positive story in the middle of a very dark time. So I think all those things together make it well worth it.
Thanks, Rich and Melissa. Go to a couple questions from the phone. Our next question is from Alex Whitsey from Nature Magazine. Your line is open. Go ahead.
Great, thanks very much. My question is for Dante. You talked about the pace at which science would be done, but can you talk about how the results are going to be made public? Like, how quickly will we get publicly the information that you're getting in the science back room? Can you talk a little bit more granularly about what and how you expect to roll stuff out? And I just want to put in a plug for as much as possible early on, even if it's tentative, please.
You bet. Thanks, Alex. Great to hear from you. And I agree. I am all about getting the information and the excitement out to the American taxpayers. Thank you, because you are paying for this and you deserve to know as quickly as possible what we're doing, and for the world. We have partners in Japan, we have partners in Canada, and partners in France, and all over the world, Australia. And so we'll have a press conference right now scheduled for October 11th, where we'll be giving what we've learned over those first couple of weeks from opening the capsule. I'll be at the American Geophysical Union in December in San Francisco with a scientific presentation. We expect, we're working great with the NASA comms team. Thank you for organizing this amazing event. And they want to tell the story, right? They're always saying, what can we say? What do we want to put out there? And so I'm really dedicated to that. I expect I'll have a first paper written by the end of the year. That's my goal right now. And that'll be a basic description and also testing the hypothesis about how well did we predict the sample. One of the big parts of the mission is we look at these asteroids with telescopes, some of them with these spacecraft, but you're always trying to figure out what exactly is it made out of. You don't have it in your lab, you don't have it in your hand. So we want to understand how well we did, and that's what my paper will focus on. We'll have follow-on papers from our mission sample scientist, Dr. Harold Connolly from Rowan University, telling us about the general nature of the rock types that we're seeing and how it fits into the other hypotheses that we're testing. And then we have a series of papers we're expecting to publish from our working group leads, and we're hoping to have those submitted in the first quarter of 2024.
Thank you. I think we have time for one more question. We're going to go to the phone. Jeff Faust with Space News. You're up next, and your line is open. Go ahead.
All right. Good afternoon. A question for Rich Burns. You mentioned the criteria for the go, no-go decision for the capsule release. I wonder if you could outline any sort of scenarios that might lead you to make a no-go decision, and what sort of contingency plans you would have in those scenarios. I know Dante mentioned a possibility of coming back around in a couple of years and trying again. Thanks.
Yeah, that's right. So one of the scenarios is if we had a problem with a sequence of maneuvers leading up to the release, and that would cause us to, if we were projecting that we were going to land outside of our prescribed landing area, we would make a no-go decision for safety reasons. So you're right, you heard correctly, we do have an opportunity. As I said, the divert maneuver will put the spacecraft, and we decide to hold on to the capsule, it will remain with the spacecraft. Spacecraft will fly past Earth, be on an orbit around the sun, and in 2 years' time, we can have another opportunity to target the Utah Test and Training Range.
Okay.
I do want to say one last thing, right? I failed to mention. I want to extend my thanks and gratitude, all our thanks and gratitude, to our wonderful military partners here at the Utah Test and Training Range in Dugway. They've been we couldn't do this without them. Not just because this is an amazing place, but because their hospitality and their cooperation and their level of expertise, competence, and just cooperation, sense of cooperation and spirit of cooperation has been extraordinary. We couldn't be happier to be in partnership with them.
They are part of the OSIRIS-REx team, and that is something really special. It's hard to explain if you haven't been part of it, but it really is this feeling that you're part of something greater than yourself. And our military colleagues are welcome and wonderful additions to that family.
Okay, thank you very much to our panelists. That's all the time we have for today. Again, let's take another final look at that beautiful drop test footage from earlier. And remember, in 24 days, you can join us to watch the real OSIRIS-REx sample return from asteroid Bennu come down here to Earth in the Utah desert just behind us. In the meantime, follow along for mission updates on the web at nasa.gov/OSIRIS-REx. And again, on the morning of September 24th, wherever you get your NASA streams at 10 a.m. Eastern Time, please join us to watch the entry, descent, and landing and recovery options all in real time on this historic mission. Again, thank you to the Army and the Air Force, not only hosting us, but really enabling these operations. And thank you very much. Go OSIRIS-REx.
OSIRIS-REx is NASA's first asteroid sample return mission. It launched in September 2016 on a journey to explore a near-Earth asteroid called Bennu. After arriving in 2018, OSIRIS-REx spent nearly 2 years orbiting Bennu, mapping and studying its rugged terrain before carrying out its primary science objective. On October 20th, 2020, the spacecraft ventured to a small crater in the asteroid's northern hemisphere. It dodged jagged rocks and towering boulders and plunged its arm into the loose surface, excavating 6 tons of debris while collecting about 250 grams of material. OSIRIS-REx stowed its bounty and closed its sample return capsule. It bid farewell to Bennu in May 2021, embarking on a 1.2 billion-mile cruise back to Earth. Now, 2 years and 4 months after leaving Bennu, OSIRIS-REx is closing in on the place where its journey began. On September 24th, the spacecraft will approach to nearly 63,000 miles from Earth. It will power up and release its sample return capsule at 4:42 a.m. Mountain Time. The capsule must be jettisoned within a narrow time frame and at just the right angle to hit its target, an area of roughly 250 square miles in Utah's West Desert. Once the capsule is away, OSIRIS-REx will fire its thrusters to avoid colliding with Earth. At 8:42 a.m., the capsule will streak into the atmosphere at a blistering 27,000 miles per hour. It will race across the western U.S. and begin to glow with heat, allowing infrared trackers on the ground to chart its progress. As it pushes deeper into the atmosphere, the capsule will rapidly decelerate, subjecting the Bennu samples to a punishing 32 Gs. About 2 minutes after entry, it will slow to Mach 1.4 and deploy its drogue parachute, stabilizing its descent. The capsule will enter special use airspace at 8:46 a.m., almost 10 miles above the Department of Defense Utah Test and Training Range. Radar stations will lock on and track it to within 30 feet of its landing site. At 8:50 a.m., the capsule will extract and deploy its main parachute 1 mile above the ground. It will make its final descent at a leisurely 11 miles per hour, like a marathon runner savoring a victory lap, before touching down in the desert soil at 8:55. After ground teams retrieve the capsule, the Bennu samples will be taken to NASA's Johnson Space Center in Houston, Texas. The sample canister will be opened in the Astromaterials Acquisition and Curation Facility, and the samples will be curated, distributed, and studied for decades to come. Having delivered its cargo, the OSIRIS-REx spacecraft will depart Earth, but its journey will not quite be finished. In a daring encore, the renamed OSIRIS-APEX will enter an elliptical orbit of the Sun, repeatedly passing within the orbit of Venus and pushing the limits of its thermal design. Beginning in 2029, it will chase down and investigate Apophis, a 1,200-foot stony asteroid destined to make an exceptionally close flyby of Earth. After 13 years in deep space, at the start of a new decade, alone on a new world, the journey will continue.